We've done a lot to improve the security of this code and to improve the readability of our abstraction so that developers can use it in a way that's secure. But there's still more that we could do to make our abstraction a little better designed. And this is actually a very important issue that we want to address. One of the problems that we have is that our current state of our code is set such that its behavior is insecure by default. Now, what do I mean by that? Well, this Boolean that we are passing in to determine if something is stored securely or insecurely, well, by default, it's going to be insecure. Now, the reason for this is let's say that we have a class that defines our security settings. And we'll just call this settings. And then we create a Boolean variable within this class. It's a member variable, and we call it secure. The problem is that by default, if we do nothing, if we don't initialize a value for secure when we declare it, it's going to be false. And this is not what we want in our code. We want the default state for our code to be secure. So what we need to do when we design our code is try to ensure that if the developer or the user or caller or whoever it is of our code does absolutely nothing to change its behavior, then by default it will do something securely. If the person or the caller or the interface user uses our code and wants to use it insecurely, they have to go out of their way to do that. We want to build abstractions and interfaces that are hard to do the wrong thing with. And that's not what we have right now with our current setup. If somebody is using our code and they call store data, by default secure is going to be false because Java Booleans, by default, if nothing else is provided when they are initialized, they're going to be initialized to false. So by default, this code is going to execute the else branch. Unless someone tells us that the code, the data needs to be stored securely, we're going to assume it doesn't, and we're not going to store it securely. And this is not how we want to build our abstractions. What we want to do is we want to build our abstractions so that it's hard to use them incorrectly. That the low energy, low effort way of using our code is to use it correctly and securely. The high effort, high energy way of using our code is to use it insecurely. And what that does is it makes it so that we can rely on the fact that developers are lazy, that code typically does not try to be more complex than it needs to be, well, not necessarily at least, to ensure that our interface normally when it's used is going to be easier to use in a secure way and less likely to have errors introduced from a security perspective. So how could we improve the security of our code in this case? Well, a better design for our abstraction would be to change the Boolean variable so that the Boolean variable indicates if the user wants the data to be public. So that by default, this conditional logic is predicated on whether or not the data should be public. And if the data is not explicitly flagged to be public, then it's stored privately using encryption or other means. And if we take this approach, suddenly our conditional logic is a lot more robust and our interface is a lot more robust. It's going to be hard for developers to take this and mess it up, or at least harder than it was before, because now the default state is to be secure unless somebody tells us not to be. But although this code is good, is this as good as we can get it? Can we make it any better? Hopefully you can see some ways that we could possibly improve on this code from the state that we've already got in it. What could we refactor to improve it even more? Well, one issue with this approach to passing a Boolean value in is that it doesn't make it immediately obvious to a reader of our code whether or not a particular statement to store data is secure or not. If somebody looks at this code, they have to actually understand how that Boolean value is used in order to determine if the data is being stored securely or not. And if that person that's looking at that code has never encountered our interface or our method calls before, the only way that they're going to be able to know if this is a secure way of using this data storage system is by actually digging into the data storage system's code and looking at how the different Boolean values are used. And you can imagine also sometimes in compiled code, the actual naming of the variables through obfuscation or other things can be changed. So we want to make it really obvious to people reading the code, even if they don't have the code available to them on how the actual implementation works, that what they're seeing is a secure storage of data or a secure usage of that code base. And right now, we've simply got Boolean values. The other thing is, because they're Boolean values and the way they're being used, it could be misinterpreted. And you could look at this code and say, you know what, they're passing in false. That means they are not storing the data securely, because someone could assume that a true value is what you use to indicate something secure versus insecure. So our naming here of our interface isn't very helpful to users who are trying to audit this code or understand its security. So how can we fix this? Well, one simple approach to improving the readability of our code and the clarity of our interface is to incorporate a enum to represent the security level. Now, you could do all kinds of things for this enum. We're going to come up with a very simple example of having two security levels, of either no security or max security. In reality, you would probably maybe want something like encrypted and private, or not encrypted and private. But the key point here is that introducing this enum allows us to have much more readable code. If we see down below, where we were originally passing in a Boolean that just said true or false, and didn't really tell us much. You know, is this code secure? Is it not secure? I can't tell from true or false, or it's not immediately apparent. I have to dig down into the code. If we look at this code, we see store data, we see some data and a key that's being stored, and then we see security level max. It's much more apparent what the intent of this code is. It's much more apparent that the developer is intending to store this data securely. And for people who are reading our code, other developers who are part of our software engineering team, it makes it more readily apparent what your code is doing. They don't have to worry as much about digging deep into the details. And also from the standpoint of code and security auditing, we always want to put less mental effort on our security auditors to make sure that we're doing the right thing. We want to make sure that our other developers don't have to think too hard about whether or not something is secure. They can look at it and tell immediately. So if somebody's looking at this code, they can very easily see, I have some data and it's clearly being intended to be stored securely. And then they can make the decision on whether or not that data should or should not be stored securely. Similarly, the data that's being stored publicly, they can look at that data and they can see that the security level is set to none. And they can then say, am I okay that there is no security associated with this other data that's being stored? One other important property of this code is, although we have switched to this enum approach to representing the security level, we still haven't changed our code so that it still defaults to a secure behavior. So no matter what, the default branch of this conditional logic is to store things securely. Unless somebody explicitly tells us that they want to store something insecurely or publicly, we try to default to storing things securely. So we're maintaining that ability to have a default of securing our data, or a default of secure behavior for our application.